Hello, my name is Oliver Maiß and I am the head of the Research and Development Department here at ECOROLL. Today, I would like to show you how you can modernize your press shop and implement a fully automated process chain in your press shop. I recently presented this idea together with my former colleague Dominic Brouwer from PICUM MT at the VDI conference, Innovative Sheet Metal Processing. After his time at the Institute, Dominic founded a company called PICUM MT, with which he has been pursuing a very innovative idea. He no longer wants to bring the component to the machine, but rather bring the machine to the component. And in our view, the combination of his technology, that is, this mobile machine tool and mechanical surface processing, can completely modernize the press shop. The press shop is truly a fundamental element of the automotive industry. Why is that? All manufacturers invest an enormous amount of money in the design of their vehicles. When I buy a car, the very first thing I see is the bodywork, then the interior of the car, and only after that do I experience how the car drives. And that's why vehicle manufacturers invest an incredible amount of money in creating an appealing and innovative design for their vehicles. But what results from this are extremely high manufacturing costs. More than 80 million vehicles are produced each year. Each of these vehicles has its own body, and this body is not made from a single sheet metal part, but from up to 300 individual components. And each of these individual parts is produced using several pressing tools in multiple stages. This means that, in the end, a set of tools for a single car represents an investment of over 100 million euros. The initial investment for this set of tools is factored in by everyone. What really becomes problematic from an economic perspective are actually the adaptation costs. So when tools need to be adjusted, if there are failures, like a breakage in a tool needs to be repaired, or a mold needs to be slightly modified. If the manufacturing tool is already present in the press shop and is actively producing components, then extremely high costs will inevitably arise when the tool undergoes modification during ongoing production operations. Dominic once meticulously compiled some important figures from a past project and then presented a compelling case where a particular tool needed to be carefully adjusted. A repair was supposed to be carried out on the tool, but the tool had to be transferred from the actual press shop to the tool-making department. And that's where the whole thing was repaired. It was then sent back and forth several times. And in the end, I'll summarize this a bit more briefly now, the tool was only back in productive use on the line after more than 100 days. That means the tool was shipped around the world for over 100 days. Ideally, the press shop and the tool-making department are located in the same building or at the same plant. In the worst case, the tool-making department is located on a completely different continent, and yet the tool still has to be shipped from A to B, because every tool machine and every press machine as well behaves slightly differently. Even if there is an identical machine in the tool-making department as in the press shop, which of course many automakers do implement. Even then, there are small differences that make things a bit different, and that's why the tool always has to be tested in real operation and then adjusted again. What Dominic can now achieve with his machine is that he can prevent the tool from being shipped back and forth. Instead, he simply ships his machine along with personnel to the press shop, and there, on site, the tool is taken out of the line, placed next to the machine. Again, this is a bit simplified. There, it is repaired, polished, a tryout is carried out, and then the tool can be reinstalled and immediately put back into live operation. What Dominic was able to demonstrate here is that he was able to reduce the processing time or lead time for such a tool adaptation from over 100 days to around 30 days. At the same time, the costs for this are also significantly reduced. He is talking about more than 50% cost reduction that is made possible as a result. However, the question now is, I still have to polish it by hand. I still have to manage a manual polish of this tool to achieve that extremely smooth surface that really meets the requirements for these forming tools. And now we asked ourselves the question, isn't it possible to combine both technologies, namely the mobile machine tool with automated mechanical surface finishing? So what if I could install a hammering tool or a roller burnishing tool in such a machine, and then on site, instead of manual polishing, I could, let me put it this way, almost completely finish smoothing my component? In the end, I only need to polish out the very last tiny imperfections from the surface, so to speak, to truly achieve the final surface geometry or surface topography, but I can significantly reduce the costs beforehand, and above all, I can make the process reproducible. I can use roller burnishing, for example, if I use a hydrostatic tool in which a ball is pressed onto the surface with a hydraulic medium. The ball then rolls over the surface and deforms the surface peaks. Thanks to the spherical shape and the geometry of the tool, I can also perform this process 5-axis. So I can really move the ball freely. I don't have any preferred rolling direction, no preferred machining direction, and this way I can also create a smooth surface on complex forming dies. To show you that this really works, I'd like to present an application example from mold making, where we once machined a cutting tool used in car body manufacturing. This tool here is already very hard, with a hardness of 56 HRC. It's a typical material for these cutting tools, and there are already very high demands on the roller burnishing process itself. For the process, we used a so-called HG tool, that is a hydrostatic roller burnishing tool, so that the ball can move freely as needed. And we specifically machined the cutting surface. This resulted in enormous benefits for the customer. On the one hand, they were able to completely replace manual polishing with an automated process that takes place in a single machine. In this case, since there weren't extremely high, like really high requirements for surface quality, it was possible to fully replace this process. What comes with that is a very significant reduction in processing time. Here, we reduced the processing time between manual polishing and roller burnishing by 95%. So from over 4 hours of manual polishing, we were able to reduce the whole process to just a few minutes of machine processing. By automating the processing, I was naturally also able to significantly increase reproducibility here. Machine processing reduces errors in the manual process and thus ensures truly consistent quality of the cutting tools. And the surface roughness value we achieved here was an RZ value of 1.4 micrometers, which is not yet a polished, so a really truly polished surface. Of course, that's significantly smoother. So the outer skin of a car has to be smoothed out much more, but for this cutting tool, that's sufficient. And what we also noticed afterwards is that the cutting performance of our tools improves even further as a result. So the tools have better cutting behavior than the manually produced tools. So it all seems to be working. Both we at ECOROLL and at PICUM would be very pleased if we could soon implement this automated process chain and demonstrate it in a real process. As I previously mentioned, the fundamental idea itself was exceptionally well received at the recent conference, and I am genuinely looking forward to the very first practical implementation projects for this innovative concept.